In electronics, we often get expressions involving the sum of sine and cosine terms. It is more convenient to write such expressions using only one single term. So here we will uh, write this sum of cosine and sine to be a single term. So the problem is how we can convert the left hand side to be the right hand side to be the single term. So the solution will be to expand the left hand side first or the right hand side at the first. Okay, but it is easier to expand the right hand side first. So we will see the requirement. Okay, I've, as you know the sine a plus b. Okay, this is a review. Sine a plus b is equals to, yes, correct, sine a cosine b plus cosine a sine b. Now we will use this formula to expand r sine plus alpha. So how do we do it? Now we have gotten that left hand side is left, not expanded, so it stays still. So it will be like this: sine theta equals r, and we expand the sine theta plus alpha to be in the bracket sine theta cosine alpha plus cosine theta sine alpha using the formula above. Okay. Now since we have this one, we will uh, simplify this using the usual multiplication or the distribution property. So it will be r sine theta plus sine theta cosine alpha plus r cosine theta sine alpha. Now we are equating each term in this equation or in this expression from the left to the right hand side. So if we find that here is a cosine theta, it will be equals to the term at the right hand side which consists or which contains cosine theta, which is this term. So we'll write, because using the equation or equating both sides, so we have a cosine theta equals r cosine theta sine alpha, and we will simplify this because it has been cancelled. Cosine theta, we have the same cosine theta at the both sides, so we can cancel cosine theta, and the result will be a equals sine theta. A equals r sine theta. This is our first modified equation. Okay. With the similarly with the same equation, we obtain that b actually b sine theta equals r sine theta cosine alpha. So right here. cosine alpha. Now, because we have sine theta both sides, we can divide both sides using sine theta, so they will be cancelled, and the result gives b equals r cosine theta. This is our second modified equation. So if we divide uh, the first and the second equation, we will obtain from both sides. Okay, we will obtain that. Actually, if we compare them, so we modify those equations to create tangent, which is sine over cosine. So it will be sine r sine theta, r sine alpha over r cosine alpha equals a over b, a over b. So here we'll obtain, as we can cancel r, and sine alpha over cosine alpha will be tangent alpha. So we obtain tangent alpha equals a over b, or alpha is the arcus tangent of a over b, or the inverse tangent of a over b, and we usually do this using calculator, or if it is spatial angle, you can guess the value of the angle. So this is the first requirement for the expression. Now, using these equations, the first and the second equations, we can also modify them by squaring the first and the second. So if we square the first equation, so it will be like a equals r sine alpha. Let's put all together with b here, r cosine alpha. And now we are trying to square both sides in the first equation, and this will be square too. So the result will be a square equals r square sine square alpha. Similarly, if we square the second equation, so b square equals r cosine alpha square will give b square equals r square cosine alpha, cosine square alpha. So what do we get if we have this modification? So if we think about the term sine square and cosine square, it will give 1 if we add them all together. So if we add them all together, it will give the new result, which is a square plus b square is actually r square sine square alpha plus r square cosine square alpha, which is, we can simplify this better. A square plus b square equals r square. Factorize r square from both terms, so we'll get r square times sine square alpha plus cosine square alpha. Because we have known about the identity, the trigonometric identities, especially for this one, sine square alpha plus cosine square alpha is 1, so we can simplify, this becomes a square plus b square equals r square times 1, which is r square equals a square plus b square, because r should be positive and r never negative. So we put here that r equals a square plus b square, square root of a square plus b square, and that is the second requirement that we obtain. So now in our mind, the sum of cosine and sine can be expressed into a single term using these two conditions. The first one is r equals square root of a square plus b square, and this one, the angle must be the inverse tangent of a over b. So we can rewrite here that actually a cosine theta plus b sine theta equals r sine theta plus alpha. We will write here a cosine theta plus b sine theta equals r sine theta plus alpha with these two conditions. The first one is r equals a square plus b square, and the angle alpha should be the inverse tangent or arcus tangent of a over b.